China's Mars orbiter captures a rare glimpse of the three-eye atlas, the interstellar visitor rewriting rules. And this comes as NASA still continues to remain silent, holding back some crucial information.
Something strange unfolded the moment Three-Eye Atlas slipped back into view from behind the sun. Instead of the jagged, chaotic form astronomers were bracing for, it emerged as a perfect green globe.
We've got a big update, a huge update on our favorite interstellar object. It could be the biggest update in the solar system.
Polished, uniform, and eerily intentional. The transformation was so uncanny that NASA and the Department of Defense quietly redirected their gaze toward it. In this investigation, we break down what scientists have just detected forming around Three-Eye Atlas, and why its new shape is sparking more questions than answers. A sky full of questions. The first real shock didn't come from billion-dollar observatories or institutions with acronyms stitched onto their jackets. It came from everyday stargazers, the kinds of people who spend their nights bundled in blankets, sipping warm drinks and photographing the sky simply because they love it. Amateur astronomers were the first to notice the strange green sphere long before any agency even blinked.
How amazing is it that we humans have a word for something that literally flies between stars, and so far...
A man in Wales was the accidental pioneer. Just after midnight, after stacking a handful of exposures into one crisp frame, he ended up with something no comet should ever look like. A smooth, perfectly shaped green orb with no tail, no haze, no hint of disorder. It looked more like a polished marble than anything cosmic. The photo was so unnervingly clean that it raced through forums faster than anyone could verify it, drawing in observers who quickly began digging through their own data. And then the flood began. Within hours, matching images started surfacing from Toronto, Osaka, Madrid, 3 cities with drastically different skies, climates, and telescope setups. Each photo showed the same impossibly bright circle, the same lack of dust or debris, the same spherical perfection. People weren't just shocked, they were confused. How could so many observers using wildly different instruments capture an object that behaved as if it were posing deliberately for every camera? The consistency was hard to ignore.
And we have a better idea of the orbit of this object. This might be a brand new, unknown, potentially hazardous asteroid.
It pushed amateurs to go full detective mode, scrutinizing their equipment, recalibrating their rigs, and running tests just to prove to themselves that nothing was wrong on their end. Some even uploaded their raw FITS files for others to analyze, noise checks, histogram stretches, exposure breakdowns, because the green was almost offensively vivid, the kind of color that makes you wonder if your monitor is lying to you. But every test returned the same verdict. The object was exactly as green as it appeared.
From images, we also saw that this object is active, which is an indication that this object is in fact a comet.
It didn't matter if someone used a tiny backyard reflector or a high-end CCD rig worth a small fortune. Three-Eye Atlas refused to smear, streak, distort, or stretch across the frame, even during long exposures where real comets always betray a little motion. This thing, whatever it was, stayed unbelievably steady. That stability only made the whole situation stranger. Anyone who's spent time photographing comets knows that long exposures always reveal motion. The nucleus shifts, the coma smears, or the tail frays at the edges. But the shots of this object? They looked like someone had paused it in space.
This comet's really cool because it does have that tail from the sun's radiation blasting it, but it also has a forward-facing tail.
A forum moderator eventually pinned a jaw-dropping image from a school observatory in Maine. It showed a perfect circle with uniform brightness in every direction. Measurements revealed the luminance varied by only about 3%, a degree of evenness practically unheard of for natural objects traveling at that speed. It didn't help that earlier images from July and August depicted something totally different, a standard comet behaving exactly as a first-time visitor to the inner solar system would.
We've got some fresh images of Three-Eye Atlas, a third ever interstellar object observed from Earth.
Back then, the Hubble telescope had captured a glowing nucleus wrapped in a wide, expected coma, with sunlight teasing dust streams off its surface like threads unraveling from an ancient tapestry. Everything about those early frames checked out. A heating, icy body, shedding material, its brightness rising the way thousands of comets before it had done. Nothing strange, nothing cinematic. And then came October 25th, 2025. the night the universe decided to remind everyone that it still has plot twists. James Webb, Hubble, Gemini South, Teed Observatory in the Canary Islands. All those powerhouses quietly doing their nightly watch, scanning the dark for anything unusual, until something finally broke the calm. At first it was nothing special. A flicker, an odd reading, a tiny visitor moving along a peculiar path. Routine stuff. But then the data stacked, and suddenly it wasn't routine at all. The object, 3I Atlas, only the third confirmed interstellar traveler humanity had ever seen, wasn't just drifting through our solar system. It was misbehaving.
This is the first time something like that is observed, where there is a glow ahead of the object towards the sun.
In high-resolution images from Gemini South and Teed Observatory, astronomers noticed something that shouldn't have been possible outside of science fiction. The comet's tail was pointing toward the sun, not away from it. That alone was enough to make astrophysicists sit up straighter. A comet's tail is supposed to be pushed away by solar wind and radiation. That's one of the most basic cosmic laws. But this thing? It looked like it was thumbing its nose at the sun. At first, researchers chalked it up to perspective tricks. Maybe an optical illusion, maybe a flare, maybe Earth was at some weird angle. But then more frames rolled in, and more, and more. The tail stayed sunward, narrow, bright, unnervingly stable, like a cosmic jet firing directly into the sun. Within a few hours, the comet that wasn't acting like a comet had become a classified curiosity.
It's easier for me to think this is a new kind of object that requires way more study than we've given it thus far.
NASA began cross-agency analysis. Observatory data streams were encrypted, and somewhere deep in Webb's logs, a simple line appeared. Sunward anomaly confirmed. When the first processed images hit public channels, they didn't help calm anyone down. The nucleus glowed. The coma formed a sleek teardrop shape, and that bizarre plume, thin, sharp, impossibly steady, shot straight toward the sun. Astronomers stared at their screens like the universe had glitched. Could it be a jet? A vent of gas and dust blasting from a crack in the comet's sunlit side? Sure, that happens. But natural jets don't behave like this.
Even if it's just a small one, that the comet is artificially made, meaning it's alien technology.
They sputter, flicker, fade. This one didn't. It stayed perfectly consistent, hour after hour, like a machine humming. One observer summed it up best. This is like watching smoke rise downward. By that point, 3I Atlas had become the obsession of the astronomical underground. Engineers rechecked calibration frames. Data analysts combed through logs. All the errors they hoped to find simply weren't there. The object wasn't glitching. It wasn't misread. It was real. Officially, 3I Atlas first spotted it on July 1, 2025. At first, it looked like just another icy wanderer. But its orbit wasn't elliptical. It was hyperbolic, the signature of a visitor from outside our solar system.
Is that it's moving along a trajectory that is very special.
It was expected to graze the sun around October 29th or 30th. By then, every major space agency on Earth was locked onto it, collecting every photon like the universe had handed them an exam with no answer key. Normally, comets display two tails, the ion tail, straight, driven by solar wind, and the dust tail, curved, heavier, following the same basic direction. But 3I Atlas refused to follow any of those rules. Some tried calling it an anti-tail, which can happen under rare viewing conditions. But even that explanation collapsed. The geometry didn't match. The plume was too bright, too solid, too persistent.
The plume of gas around it is mostly carbon dioxide, 95% by mass, based on the Webb telescope data.
If matter was truly being ejected toward the sun, it meant something that would rewrite entire textbooks. And yet, every instrument agreed. When the images went public, the internet erupted in chaos. Reverse tail theories, alien engineering jokes, solar magnetism debates. But inside the observatories, the mood wasn't excitement. It was a creeping unease. It's one thing for a comet to look odd. It's another for it to break the laws of astrophysics in real time. As the solar flyby approached, the readings only got stranger. Chemistry didn't match expectations. Spectra hinted at something unfamiliar. Every fresh dataset seemed to contradict the last. By late October, observatories were running non-stop. Some scientists classified the object as an anomaly. Others called it a once-in-a-lifetime gift. But underneath every calculation and every paper draft was the same quiet realization. The deeper we looked, the less sense it made. Whatever this was, it wasn't just dust or gas. It wasn't just a plume. It wasn't just a comet. And scientists kept firing off theories. But every explanation only dug the mystery deeper. When the universe breaks character. The moment 3I Atlas rounded the sun and reappeared on the other side, the entire mystery took a sharp turn. Everything scientists thought they understood, every model, every expectation, every prediction, collapsed in real time. Months of consistent behavior vanished overnight. The object emerged not as the ragged, sun-scorched comet everyone had prepared to analyze, but as a flawless sphere.
It was the very first object that we'd ever discovered that had originated outside the solar system.
Polished smooth like someone had sanded it down. A comet that dives close to the sun is supposed to get messy. Solar heat tears apart the surface, releasing clouds of gas and dust that erupt into bright jets and tails. That's textbook behavior. It's practically tradition. But when this object showed its face again, all the expected chaos was gone. No jets, no tails, no plume, just a silent, impossibly clean orb drifting across the darkness as if nothing in the universe could touch it. Researchers were baffled. This transformation didn't match any natural pattern humans had ever documented. Instead of becoming brighter and more chaotic, as every comet in history does after perihelion, the thing became smoother, dimmer, and disturbingly uniform. Images from observatories around the world backed this up. Different telescopes, different sensors, different vantage points, and yet every frame told the same story.
3I Atlas comes back into view. Right now, it is hidden behind the sun, and during its closest approach, Earth-based telescopes are not going to be able to see it. What's worse,
the object's outline was perfect. The sphere unbroken, the surface evenly lit. That level of consistency practically screamed, "Nope, this isn't a camera glitch."
There's a mysterious interstellar object hurtling towards our solar system, exciting scientists across the globe.
Unusual angles were ruled out. Instrumental errors? Gone. When dozens of independent observers show the same phenomenon, the universe is usually trying to say something. And this one wasn't whispering. If the comet had shattered during its closest solar approach, as many comets do, then the images should have been filled with debris, dust clouds, fragment trails, sheets of particles peeling away. But not a single observation showed so much as a faint streak. The sphere floated alone, untouched, no haze clinging to its edges, no drifting fragments. Not behaving the way a real comet behaves when stressed by solar radiation, long exposure images should have revealed at least some particles wandering off the core. Even the tiniest shards usually leave faint scratches across the frame. But here, silence, stillness, a solitary orb defying the rules. Observers pushed deeper. They studied brightness patterns, searching for irregularities or shadows, anything that might betray cracks, uneven terrain, or hidden jets. The object refused to give up a single flaw. And that's when things got even stranger. Because when physics stops cooperating, scientists normally turn to guesswork. But this time, even the guesses fell apart as quickly as they were proposed. Across observatories, research centers, and mission rooms, the world's top astrophysicists found themselves staring at screens like they were witnessing a cosmic prank.
3I Atlas. It does give scientists a rare chance to study something from beyond our solar system.
Simulations flickered helplessly. Equations sprawled across whiteboards only to be erased minutes later. At first, the explanation seemed straightforward. Maybe the comet had a sunward geyser, just a pocket of frozen gas venting from the illuminated side. Not unheard of. Comets throw tantrums like that all the time. But that idea died quickly. Natural geysers are messy, flickering things. They erupt, sputter, fade. They do not remain steady for hours on end. Then came the kicker, a countertail. The traditional tail trailing away from the sun, just like a comet is supposed to have. That meant there were two tails, one defying physics by pointing straight toward the sun, and another behaving normally. Two tails, opposite directions, same object. At that point, the theories started sounding like late-night dorm room speculation. Maybe a magnetic field interaction, some unheard-of ion behavior involving carbon dioxide, or something stranger, an object that wasn't being pushed by the solar wind, but was somehow feeding energy into it. The models choked. This wasn't a simple reaction to sunlight. 3I Atlas wasn't just resisting the solar wind, it seemed to be negotiating with it. Meanwhile, the chemistry quietly threw gasoline on the fire. It's no longer news that data from the James Webb Space Telescope had dropped like a cosmic plot twist.
From images, we also saw that this object is active, which is an indication that this object is in fact a comet.
Its infrared spectrometer revealed an astonishing ratio: 8 parts carbon dioxide for every 1 part water vapor. That's unheard of. Not for comets here, not for interstellar comets like 2I Borisov. Carbon dioxide simply doesn't dominate like that. Yet here it was, an object practically built out of carbon dioxide. And there and then, the whispers started. Where does something like that come from? Some researchers suggested a carbon-rich stellar nursery, someplace where water ice was rare and carbon chemistry ruled. Others theorized it might just be the frozen atmospheric remnants of a dead planet, ejected billions of years ago and preserved in cold darkness. And then came the theory nobody wanted to say out loud, but everyone thought anyway. If the jet was carbon dioxide driven, was this object simply a new kind of comet or something engineered to behave that way? No one put that in a journal article, of course, but behind closed doors, the word artificial made a few rounds. The puzzle wasn't done growing.
And we have a better idea of the orbit of this object. This might be a brand new, unknown, potentially hazardous asteroid.
Spherex, the spectrophotometer for the history of the universe, epic of reionization and ICE's explorer, added another twist. It detected massive amounts of vaporized carbon dioxide in the coma, along with small traces of water ice buried deep in the object's core. That combination shouldn't exist. It was a chemical fingerprint both familiar and alien, like someone stirred together ingredients from 2 different solar systems and hoped no one would notice. Spherex's finding of very large amounts of vaporized carbon dioxide told us it could behave like a normal comet, said Kerry Lise of Johns Hopkins University. But the proportions are what make it fascinating. He explained that ice ratios reveal a comet's birthplace. One born near the outskirts of a solar system contains all 3: water, carbon dioxide, carbon monoxide. One that spent too long near the star loses its carbon monoxide first. But 3I Atlas didn't fit either. It was too carbon-heavy, as though it formed in a cosmic environment nobody has ever sampled. Some now believe it came from deep inside the Milky Way's thick disk, a region filled with ancient stars.
Thick disk of the Milky Way. Based on its trajectory and based on the velocity, low metallicity stars to the ancient star it came from.
If true, it would make the comet 2 to 3 times older than anything we've ever seen in our solar system. So what exactly is 3I Atlas? Whatever it isn't done rewriting textbooks, and it's clearly keeping a few secrets tucked away for later. A cosmic crime scene. Picture this. Astronomers spot something so bizarre in 3I Atlas that it feels like catching smoke behaving perfectly without any fire, or thunder politely showing up with no lightning. That's how the whole iron vanishing act began. At first, everyone assumed it had to be a glitch, a sleepy sensor, a calibration hiccup, maybe a cosmic dust sneeze confusing the instruments. But then observatories everywhere started chiming in. Hawaii checked, Chile checked, Europe checked, and every single dataset looked back at them with the same stubborn answer. Nickel vapor, present and glowing. Iron, nowhere. Nothing.
So here scientists did detect numerous nickel lines, but the iron emissions remained undetected.
Not a whisper, which is absurd, by the way. Nickel and iron are the inseparable twins of the universe, cooked up together in stellar furnaces, bonded by cosmic chemistry, and known to vaporize at almost identical temperatures. Wherever nickel goes, iron tags along.
Nickel and iron gas together. And now, in 3I Atlas, we are seeing nickel alone.
It's one of the few chemical certainties astronomers could basically bet their careers on. But 3I Atlas just took that rule, folded it into a neat paper airplane, and threw it out the window. Naturally, mild scientific chaos followed, the calm, professional kind where everyone pretends they're not freaking out while definitely freaking out. Instruments were fussed over, data was reprocessed within an inch of its life. Independent teams ran blind verifications, and the universe continued trolling them with the same result. Unmistakable nickel, absolutely no iron, zero, nada. That's when the theories started swirling like cosmic gossip. The leading contender? Nickel carbonyl compounds, delicate, strange molecular structures formed when nickel binds with carbon monoxide. These things barely survive in controlled laboratory conditions, let alone the unforgiving vacuum of space. Maybe, just maybe, they could form in ultra-cold interstellar clouds where atoms behave like they're having an identity crisis. But even then, they shouldn't be intact after cruising through space, taking a solar flyby and politely presenting themselves to our telescopes. So if they did survive, what on Earth, or not on Earth, preserved them? And here's where the story tiptoes from weird into vaguely unsettling. Nickel carbonyl compounds are not only rare.
Nickel reacts instantly, forming a colorless toxic gas called nickel carbonyl.
They're industrial, human industrial. On Earth, we use them for metal purification. Synthetic, fragile, intentional molecules engineered for precise processes. You can imagine the collective eyebrow raise in the astrophysics community. Most scientists brushed off the comparison as coincidence. Others paused. If 3I Atlas was venting nickel-rich material in a tight directional plume, and if that material contained molecular structures nearly impossible to create naturally, then, well, the universe had just opened a door nobody was eager to peek through. The kind of door labeled, "What if this isn't a normal comet at all?" Nobody's writing that theory in any peer-reviewed paper, at least not unless they enjoy academic exile. Official language remains cautious, padded with maybes and possiblies and more data needed. But behind the curtain, let's just say certain government facilities started making oddly urgent requests. Observatories received priority flags they'd never seen before. Data that usually trickles in suddenly needed to be streamed live and uninterrupted. Somewhere, someone decided this object wasn't merely interesting, it was important. Dr. Daryl Z. Seligman from Michigan State University summed it up in a way that almost undersells the madness. We've detected glowing nickel vapor in the gas surrounding 3I Atlas at a distance far too cold for metals to normally vaporize. It's an extraordinary result, one that changes how we understand material chemistry beyond our solar system. Translation: this comet is breaking the rules, all of them.
Reasons we are able to get any of the observations and interpret any of them so far is because this object is so obviously a comet.
That's the thrill and the existential dread of interstellar objects. They're not just cosmic tourists. They're time-sealed archives of alien environments, long-dead stars, and forgotten planetary systems. Each one carries chemical secrets we could never replicate, let alone visit. But 3I Atlas? It's not behaving like a time capsule. It's behaving like an unsolved puzzle someone deliberately scrambled. With its plume defying known physics, its carbon dioxide ratio rewriting chemistry textbooks.
The plume of gas around it is mostly carbon dioxide, 95% by mass, based on the Webb telescope data.
And now iron mysteriously missing. Scientists are left whispering the question they don't dare say into a microphone. What exactly are we dealing with? A relic of ancient cosmic history, or something shaped by forces, minds, or technologies we haven't even begun to comprehend? Whatever the answer is, it has the scientific world on high alert. The cosmic anomaly no one wanted to touch. By this point, 3I Atlas wasn't just a curiosity. It had quietly crossed into protocol territory. In control rooms from Tokyo to Pasadena, the mood shifted almost imperceptibly. Screens that normally displayed calm streams of data began blinking with flagged updates. Internal memos started arriving with half the paragraphs redacted, and government reports showed up looking more like ink blot tests than documents. The voices over comms kept their composure, but underneath was that unmistakable tremor of controlled urgency, the kind that says, "We're seeing something we can't yet categorize, and it's not staying still." That subtle tension was enough for the International Astronomical Union to elevate the object to high-interest, non-local status. Not a threat officially, but certainly not the sort of thing anyone wanted drifting around without supervision. And once that classification went through, the world's major space agencies began moving like seasoned chess players making quiet, deliberate moves in a room where the lights had gone out. Network, normally slow, methodical, predictable, ran unscheduled trajectory drills and used 3I Atlas as the simulated target. Odd, since drills like that are usually reserved for objects with a small but real chance of hitting Earth. NASA's Swift telescope, built for capturing gamma-ray bursts, suddenly re-aimed a slice of its attention toward the comet.
From images, we also saw that this object is active, which is an indication that this object is in fact a comet.
The SphereX mission, meant for panoramic infrared sky surveys, quietly reallocated bandwidth to watch the object instead. Even mid-tier European observatories received discrete coordination requests, the sort of politely urgent messages normally sent when something important has started behaving in an inconveniently unpredictable way. None of this made headlines, of course, but for those close to the action, the message was clear enough. Something big was unfolding, and very quietly. One analyst summed up the mood during a private briefing, whispering as if the object itself might overhear, "We've catalogued comets for centuries, but never one that made global observatories whisper to each other. So where were we?" Let's recap the madness. A so-called comet shoving a plume of matter straight toward the sun.
This comet's really cool because it does have that tail from the sun's radiation blasting it, but it also has a forward-facing tail.
Carbon dioxide levels that broke every chart, nickel vapor with no iron, and now a global network of agencies treating it like a classified file with an orbit. And then the numbers began misbehaving. A lot of things have made the 3I Atlas an anomaly.
This object has just been discovered. 3I Atlas was discovered on July 1st by the NASA-funded Atlas survey.
When it first approached the sun, its path drifted, not from gravitational influence, but from something else. It wasn't dramatic, but it was persistent. Typically, these small deviations come from a comet's jets acting like micro-thrusters. But this time, the drift didn't align with the jets we could actually see. Instead, the object appeared to be nudged by the Sunward plume, the very plume that shouldn't exist in the first place. That's when the whispers turned uneasy, because the pattern felt hauntingly familiar. Back in 2017, Oumuamua, the first known interstellar visitor, displayed a similar non-gravitational push, a subtle acceleration that sparked a global debate. Natural object or technological artifact? Nothing was ever conclusively settled. But 3I Atlas raises the stakes even higher. Unlike Oumuamua, this object has a visible coma, with genuine material streaming from it. Yet even with that, the math doesn't reconcile. Its acceleration comes in abrupt jolts, not fluid motion, as if something inside the object changes in discrete steps.
Dust being pushed back behind the object by the solar radiation pressure.
Fragmentation, unstable rotation, some kind of cascading collapse, or a mechanism we haven't even imagined yet. Whenever an interstellar visitor starts defying chemistry and physics at the same time, it stops being a rock and becomes a full-blown riddle. And then came the moment no one expected. As the object swung closer to the sun, telescopes detected an unusual bending of the light behind it, just like Einstein's theory of general relativity predicts. The sun's gravity should shift its apparent position by 0.27 arcseconds. Instead, the displacement was 4 arcseconds, 10 times greater, impossible by known physics. Something was amplifying the effect. According to astrophysicist Avi Loeb, producing a shift that significant would require an enormous blast of gas,
and scientists will be able to study the release of volatile materials from the nucleus.
Enough to vaporize 15% of the object's total mass, roughly 5 billion tons. A blast like that should have created a blinding dust storm visible to telescopes around the world, except no dust appeared, no plume, no shattered debris. If you take the physics at face value, the only logical conclusion is that 3I Atlas isn't a comet at all, but an engineered construct. Then, as if eager to add another layer to the mystery, the object hit perihelion and suddenly brightened and shifted color. It glowed blue, not red. Comets, heated by the sun, scatter blue light and redden as they vaporize. This one reversed the script entirely. Meanwhile, the unexplained acceleration kept increasing. Not from radiation, not from jets, not even from sublimating gases, just movement without a clear driver. And its orbital plane, perfectly aligned with those of Venus, Mars, and Jupiter, the chance of that happening naturally is 0.2%. A 1 in 20,000 cosmic coincidence. At roughly 33 billion tons, 3Y Atlas dwarfs Oumuamua by a factor of 1,000,000, and Comet Borisov by 1,000. It's blasting through space at 151,800 miles per hour, faster than any interstellar object we've tracked.
We've got some fresh images of 3I Atlas, a third ever interstellar object observed from Earth.
Only 4% of its mass is water, and its brightness increased 7.5 times faster than any previously observed comet on approach to the sun. Just to sprinkle a bit more cosmic spice into the pot, It arrived from the exact same region of the sky as the 1977 WOW signal, that famous unexplained radio burst that has baffled scientists for decades. So here we stand again, on the edge of knowledge, staring into the dark with our finest sensors and our most careful equations, only to find the mystery widening instead of narrowing. Even the newest AI systems flagged this object as non-standard before human astronomers knew where to point their instruments. Maybe 3I Atlas is just a comet with an alarming list of quirks. Maybe it's an interstellar artifact. Or maybe it's something we don't yet have a word for. Either way, the universe just slid another puzzle onto our desk, and this one refuses to be ignored. Scientists just discovered something unusual forming around 3I Atlas, a cosmic red flag hidden in code. It didn't start with a human squinting at a monitor or someone catching a strange blip on a telescope feed. It started with a machine, one that normally doesn't second-guess itself. Deep inside the James Webb Space Telescope's sprawling data archive, somewhere beneath mountains of system logs and calibration records, a single muted line flickered into existence. Manual review required.
An X-ray telescope and an optical ultraviolet telescope at the possible location of the gamma-ray burst.
No klaxons, no blinking lights, just a subtle nudge from the universe's most advanced robotic observer. And what's truly unsettling is that this timestamp appeared weeks before anyone on Earth realized 3I Atlas was acting weird. Webb's AI-assisted prioritization system is usually predictable, almost charmingly so. It's built to chase the dramatic stuff. Distant supernovae blowing themselves apart, gamma-ray bursts screaming across space, stars hiccuping in ways we barely understand. Comets? Not even on its radar. They're too routine, too boring, yet somehow 3I Atlas slipped into its queue. Independent researchers stumbled upon the archived flag by accident and initially dismissed it as simple system noise. But the deeper they probed, the more the glitches evaporated and the pattern emerged. Webb's AI hadn't simply noticed the object, it had asked for permission to look again. Then things got stranger. Every object in the sky has a light curve, a record of how its brightness rises and falls. Natural bodies flicker and wobble like broken Christmas lights. Rough rock scatters sunlight unpredictably. Ice reflects in crisp yet chaotic bursts. In short, nature is messy. But the light curve for 3I Atlas? Not messy, not random, not natural. It pulsed in a rhythmic and structured manner. One analyst described the pattern as too clean, the sort of reflection you'd expect if the object had flat surfaces, like panels, catching sunlight at precise intervals. A few bold voices wondered if the symmetry hinted at geometry far too deliberate for a frozen wanderer. Was the object adjusting its rotation, stabilizing itself, mimicking the behavior of a spacecraft maintaining balance? Webb's AI did something it was never explicitly programmed to do. It overrode its default behavior. It paused its task list, flagged the anomaly, and demanded a human to review it. Then the leak happened. Within hours, the official explanation arrived, smooth, tidy, and utterly unconvincing. The anomaly appears to be a software artifact, no further investigation required. But the log timestamps betrayed that story immediately. The AI had triggered its alert before any operator touched the data. The override wasn't a reaction, it was a decision. The AI had spotted something its training had never prepared it for, and instead of quietly ignoring the anomaly, it escalated it on its own. So what exactly did it see? A reflective signature ice shouldn't produce? A surface that responded too cleanly to solar angles? No one knows. Not officially, anyway. But the question clings stubbornly to the edge of the investigation. What did the machine recognize that humans completely overlooked? It's kind of poetic when you think about it. For thousands of years, humans studied the sky with trembling awe. Ancient civilizations treated unusual lights as divine warnings. Cosmic letters addressed to kings and emperors. Comets weren't meteorological quirks. They were omens. The Babylonians believed they foretold upheaval. Chinese imperial astronomers refused to announce royal decrees during broomstar sightings. Even the Egyptians buried their pharaohs with meteoric iron, convinced the heavens were offering literal gifts from the gods. Maybe it was superstition. Maybe it was instinct. Maybe it was humanity's early clumsy attempt to say, "We notice when the sky breaks its rhythm." And now, thousands of years later, it wasn't a priest, a court astronomer, or a curious stargazer who first felt that break. It was a neural network, a machine silently watching the dark. By the time the public caught on, the internet had detonated with theories. Data miners picked apart Webb's logs line by line. Amateur astronomers cross-referenced timestamps. Coders reverse-engineered decision trees. NASA's next updates were becoming incoherent and the images unclear, which has added a new layer of mystery to the 3i Atlas. So, people started following the AI's digital breadcrumbs. The world's new frontier. Comet 3. I-Atlas currently drifts through the constellation Leo, sitting about 275 million kilometers from Earth.
We've got some fresh images of 3i Atlas, a third ever interstellar object observed from Earth.
Its right ascension hangs at 11 hours, 34 minutes, 54 seconds, and its declination settles at a modest +2 degrees, 49 minutes, and 25 seconds. With a magnitude of 11.0, it's hardly the kind of object that usually sparks a global frenzy. And yet, here we are. Because in this era where institutions speak softly, the crowd speaks loudly. And in the age of AI, live-stream telescopes, and caffeinated internet theorists, the crowd never logs off. The instant 3i Atlas popped into view, the digital world erupted like someone pulled the cosmic fire alarm. Reddit kicked open debate threads, Discord channels filled with spectral charts and wonky orbital plots. Amateur astronomers started swapping data like seasoned lab researchers. YouTubers rolled out hour-long breakdowns of solar side anomalies, while TikTok stitched neon edits of the comet slicing across the void to unsettling synth beats. And the theories? They multiplied like rabbits in zero gravity. Alien probe, broken propulsion core, rogue solar experiment, a leftover shard from some ancient interstellar machine, a cosmic lighthouse humming warnings across the dark. Hashtags exploded. Comet interceptor, stealth fragment, interstellar mirror. Everyone wanted to define the weirdness, because something about this comet simply refused to sit neatly on the shelf labeled normal. Official agencies kept their tone buttoned up and reassuring, but quietly, behind that calm facade, the pros started shifting gears. Telescope rosters were reshuffled. Tracking software got silent updates. Missions received subtle retasking. Those who watched the watchers noticed the pattern. And patterns never lie. Not panic, not prophecy, just that unmistakable signal. This deserves attention. And maybe that's why 3i Atlas has become a global obsession. Not because we know what it is, but because every new measurement whispers that we don't. What we do know is fascinating. Add in the AI anomaly alerts, systems spotting oddities before humans even looked, and the strangeness starts stacking up. So naturally, questions emerge. Is this the remnant of something ancient and artificial? A shard of engineered material shaped by forces long gone? A natural traveler that just happens to carry the physics of a region beyond our imagination? Or is it harmless? Simply a messenger from a corner of the galaxy where the rules are written with different punctuation? Whatever the truth, 3i Atlas has earned its status, an official interstellar hyperbolic comet, only the third ever confirmed after Oumuamua in 2017 and Borisov in 2019.
This new Hubble image shows comet 2I Borisov as it comes into the solar system and is starting to heat up.
And this one is big, 5 to 11 kilometers wide, dwarfing Oumuamua and rivaling the titans of our own long-period comet family. But what really elevates it is the global mobilization. Every instrument with a lens, dish, mirror, or sensor has turned its eyes toward this wandering visitor. James Webb logged infrared spectra. Hubble captured razor-sharp imaging. Ground observatories like VLT, Gemini, and Keck poured weeks into study. Even spacecraft not originally designed for comet hunting, SphereX, TGO, MAVEN, grabbed whatever data they could. Each fragment of data does more than decode a comet. It nudges open the door to understanding the interstellar medium itself, that vast, unseen ocean between the stars. Please click the cards on the screen now for more interesting videos.